Okay, so today we're going to be talking about titration. I did spell technique wrong. Okay, so how do you spell it? T-N-I. Okay, so titration is a technique that allows us to determine unknown concentrations. And really, if we are doing a titration carefully, to a pretty high degree of certainty. So in other words, we can get quite a few significant figures in our data if we use proper technique. Okay, so the beginning of this is going to be a little bit hard to manage because there's some terms and I'm going to have to draw some pictures, so just bear with me. This is how we normally set up a titration. We have the long glass tube that has the markings on the side. Does anybody remember what that's called? Starts with a B. This is called the burette. There are some real life ones on the back wall in the burette rack. They're all upside down. I just bought those new. They're actually really expensive. They're like $100 a one. So the burette is special because it has all of these markings on it. So it can help us to know exactly how much of a liquid we're delivering from the burette. So in our unit right now is acid-base. So we're going to be talking about the acid-base titration. You can use titration for a number of different applications as well. And when we start talking about redox, we'll do a redox titration as well. So in the burette, we're going to be putting our base. And a lot of the time, the base that we use is sodium hydroxide.
You drew it over.
It might be helpful. But that's up to you. Oops. Okay, this is the part that's going to be hard for Miss Bishop.
Because the drawing's burette, right?
Yes, that's the drawing is the burette. Okay, so what I want to do is draw an Erlenmeyer flask. So, you can draw that. It's the one that looks like a triangle. Okay, that's bad, but it's not terrible. In your flask, you're going to have a liquid. The liquid, if we're doing an acid-base titration, and in the burette we have the base, what do you think would be in the flask? That's right, that's the acid. Okay, so the way that a titration works is that at some point there is going to be a color change. And the color change is going to visibly tell us when we have equal parts of acid and base. The indicator that you most commonly use for an acid-base reaction is called phenolphthalein. But this is how it's spelled. Isn't that a great word? Phenolphthalein. What's special about phenolphthalein is that when it's in an acid, okay, I'm going to do this here on the pH scale. Phenolphthalein is colorless when it's in the presence of an acid, and right around the 8 pH mark is when it turns a very light pink. If the pH gets any greater than 8, so usually around 9 or 10, that's when it's going to be a dark pink. And if your titration gets to a point where the color you see is dark pink, you've gone too far. So this is what a titration is, physically. But now I want to show you what is happening chemically to make this happen. I'm just going to wait till you are done copying that down. Everybody is good? Okay. So now let's look at the chemistry of what's happening. We're starting with an acid and we're adding base to it. So what should be my two products of this acid-base reaction?
H2O
Yep.
plus HCl.
NaCl though, right? Because the Na has to come first. Okay, so what would you expect is the pH of some hydrochloric acid solution that you have? Yes. Okay, so let's say that we have a pH of 3. What would you expect the pH of NaOH to be?
11.
Okay. I agree. What do you expect the end pH of this whole reaction to be, though?
Probably like
7 and 7.
well, how do you
I have no idea.
wait? How do you
Is that true?
Yeah, it
right?
is. It is. Let's talk about that.
How do you get those numbers?
I made them up. I just thought, what would be some pH that would be reasonable for hydrochloric acid? And Dominic said somewhere between 0 and 7, right? Because it's an acid. And then what would be the pH of NaOH? Well, something over 7, right? And so 11 is fine. You can pick any number. Doesn't matter. So how do we know that the pH of the end product should be 7? What's the pH of water? It should be 7, right? 7 is the point at which your solution is neutral. What does it mean for something to be neutral? If two of your friends are in a fight and you say, I'm neutral, what does that mean? It means you're not picking sides, right? So, in the same way, in acid and bases, if you're neutral, you're not an acid and you're not a base. You're neither. And so, what we can call an acid-base reaction then, in addition to the word acid-base reaction, we can also call it a neutralization reaction. Because you're taking an acid with a low pH and a base with a high pH and adding them together and making water, which is neutral. So now going back to our titration drawing, what we're going to do is we're going to see that our indicator is going to give us this color, oops, I was hoping that it would be the pen, but it wasn't. It's going to give us this colorless representation. That's how it'll start. And as we add base to the acid, we're going to do it in a slow enough way that at the point where it changes color and turns light pink, we will have a neutralization, which means that the amount of HCl is equal to the amount of NaOH. When this is true, when you have equal parts of acid and base, you have what's called the equivalence point. In other words, the equivalence point is the point where your acid and base are equal. That's called the equivalence point. I got really anxious and wanting to change this because we're in single digits now. Although, I don't know about you, but it does not feel like a Tuesday.
What's it feel like?
Feels like a Friday.
It feels like it should be at least Thursday. Mrs. McDonald told me this morning, she's like, I woke up and I thought, I gotta get my jeans out. She's like, no, I can't wear jeans today. And I'm like, well, that's so depressing, it's only Tuesday. Okay, so the equivalence point is the point where the acid and base are equal. There is a way that we can numerically find what this relationship is. And it's using that titration formula that's on your orange sheet. So let's talk about that. titration formula looks like this. Okay, so you don't know what the N stands for yet. Let me tell you what that is. N is it stands for the concept of normality. It's a measure of concentration. So you don't need to know that it's called normality. The equation for normality is actually on your own sheet, but you don't really need that yet. What you really just need to know is that this is the concentration of your solutions. Okay, so there are two N's. One has a little a and one has a little b. What do you think the little a stands for?
I don't know.
No, it could be, but no. So you're talking about an acid-base titration. What do you think the A stands for? Acid. So this is the information about your acid. And over here we have the information about the base. Okay, so that takes care of the little a's, the little b's, and the n's. What do you think volume stands for?
So A's acid. Okay, that makes sense. I can't believe we didn't get that one.
I can't either.
Acid and B is base.
Yes, thank you.
Oh,
Yes.
that's a B?
It is a B, yes. I'm sorry, what does it look like?
That was an O.
Oh.
No, it looks like a B. Yep,
All right, what do you think the V stands for?
That's not correct.
Oh, the V. Oh, I thought you said the B. That's
Oh, I'm sorry. I'm so
Volume.
sorry.
Volume.
Yes.
Yep.
Ms. Bishop, you said that already.
I did?
No,
She said, what
no,
does the
you
volume?
didn't.
She said, what was the volume stand for?
Oh.
I didn't hear that.
I'm so dumb.
No, I didn't.
I'm sorry.
No, I did not. No, I did
I'm
not.
sorry.
No, I
The
got that
struggle
one
is
wrong.
real, my friends. You got that on your own. I know you
Yes.
did. I know you did. Okay, so let's now solve this equation for all of the variables so that in case algebra and you are not good friends, you have access to that. If you're good at algebra, you don't need to write any of this stuff down. If you're not good at algebra, though, don't worry because just write this on your own sheet.
I'm gonna write it because it's safety.
Safety first, yes. Not wrong. In fact, that's an interesting thing that you say that, so maybe you should just write it down. Because when you get to a final exam or things like that, boy, your brain can just shut the heck off, can't it? Somebody last year didn't write it down on their sheet, and I remember thinking, oh, buddy, you should be writing that down. And then he lost points on every single formula on the test because he didn't solve it properly.
Did he pass the class?
He did.
Okay. So there's still.
There is. I have never had anybody in all of my years of teaching ever fail any of my classes if they tried.
They tried?
If they tried. If you
Oh, I thought you meant
like if you try it, like if you hand your homework in, you'll pass. You'll pass, no problem. Like you pretty much can do anything else and you'll still make it. Okay, so
Don't mind it.
the nuances are very slight, but they're real. So if you miscopy any of this down right now, you're cooked.
Fair enough.
You got to make sure that. So the trick is the B's have to stay together and the A's have to stay together. So just the devil's in the details when it comes to this. Solving these problems is not hard, friends. It's being sloppy that's going to be what killed old Duke. All right, so now that we have this, I'm going to hand out your homeworks so that we can use some of these as practice.
Ms. Bishop, don't we work out homework the rest of the time?
Maybe. Maybe. If you pass one back to them, please.
Oh boy.
You guys look wrong, actually.
I gotta see that.
Oh my gosh.
Game day.
It How are we feeling?
Who's that? Your car?
Yeah.
I'm getting a buzz cut before the game.
Pokemon
card.
I don't mess up.
Are they actually Pokemon cards?
No,
I'm just gonna say that's interesting.
Did I?
All right, let's look at number one.
Next big one.
All right, what do you see underneath the words of number one? Yes.
Can you go back up?
Oh,
To the
sure.
last one.
What do you see underneath the words on number one? What does that look like on your paper?
What do you mean the words?
Well, like there's words, there's like a word problem, and then there's a thing. What's that thing?
The table?
It's a table, yes. Now, at the beginning of this homework, I have included the table for you, and then I stopped doing it because this is to train you in the ways of solving word problems to make them not word problems. And so,
I hate word
word problems are awful. We can all agree on that. But you can turn a word problem into a not word problem by doing this, and then they become easy and simple. It's just math. Okay. Can I move this now? Okay. All right, so let's look at what this says. Now, I know because it says the word neutralization in this problem. It says that word. That means I'm using the titration formula automatically. And so in my table, I know that I have 4 variables, and so I'm just going to start by making a list of them. And I know that because this is the only thing I'm teaching today, that this is going to be the only thing on this homework, you can start every problem this way. There are 4 lines here for you for a reason, because there are 4 variables. So on each line, put one of those variables.
So put those in the order sections.
That's what, yes, in this first column on each of those 4 lines. You can do any order you want. I just tend to use this order because that's the order that I see them on my titration formula. Okay, so now it's just a matter of reading the text, finding a number, and trying to figure out if it's an N, a V, an A, or a B. Dominic?
What is normality?
Normality is a way of measuring how strong a solution is.
Okay.
So the bigger the number, the stronger the solution, the more concentrated the solution.
Where would that be in the problem?
Good question. We'll find it. We'll find it. Okay, so this is probably something that you should write down. The unit for normality. So if you see a number that has a unit, a label, that is big N, so if you have number N, that's either NA or NB. How do you know? Because there's literally an N.
Oh.
That's how easy it'll be. If you see, though, number of milliliters, that's almost always your unit for volume. Sometimes you'll also get liters. That's going to either be VA or VB. So those are your 2 units. So if that first number that you see in this problem is 10.0 milliliters, that has to be a volume. So figure out if it's a volume or a normality first, and then decide if it's an acid or a base. Now, your problem will be clear enough that you can figure it out. Here it says a 10 milliliter sample of base. So it's milliliters, that means it's a V. Is it VA or VB?
Yeah.
But it says sample of base.
Oh, so we
Yes. So VB is 10.0 milliliters.
should we write that in the on the numbers?
Put that in your table next to VB equals. The next number that I see is 28.92 milliliters. Is that a V or an N? It's a V. Is it VA or VB?
B or A.
Well, it has to be A, right? Because we've already put something in there. 28.92.
How do you know that?
We already put something in
We already have
VB.
base.
But also, it does say 28.92 milliliters of something, and then H2SO4. So how did I know that was my acid? If it starts with H, yes. Okay, so then that number 0.1240 N, we've already filled the V lines, right? So it's got to be an N. Is that of acid or of base?
Acid.
If there's an acid formula right after it, it has to be Na. What about NB? That's your question mark. Okay, so now because I did give you all of the algebra already, you can skip really, I guess.
I like that idea.
In your second column, this is what I would do. Whatever variable has the question mark, that's the equation that you'll choose. So I'm going to choose this equation because that's the one that's solved for the question mark of this problem. So in my next column, I'm going to write that. In the next column, you can you can substitute the numbers into this formula. Okay, so now this is easy. Just go back to your data table and figure out what you called each of those variables. So we said that Na was 0.1240 N. Do you have to write the N? You betcha you do. If you don't, you're a sloppy chemist, and we're not having that. We said that Va is 28.92 milliliters. And then we said that VB was 10. Any questions about how I got from column 2 to column 3?
No.
Good. In column 4, you can just write your answer. So here's where you need your calculator. You need to think about your unit, and you need to think about significant figures. Oh, I like that.
0.3, that's 8.
Okay, firstly, how many significant figures should I have in this answer? 3. Because the 10.0 has 3.
Is this our fourth box?
Yep.
Will the denominator always have the most significant?
No. You just have to decide which number is the smallest number of significant figures, and that's how many you should use. What's your unit, though? N is your number. Okay, so here on the board, I even have this cheat sheet written for you. If you're solving for N, the unit for your answer should be N. If you're solving for V, your unit is probably milliliters.
Why was there only 3 significant?
This number has 4. This number has 4. This number has 3. The smallest number is your answer. I really liked how Mrs. Peter made that announcement about the phones for band. Maybe my work here is no longer needed.
You did it one day.
Yeah, I know.
For short 3.
You know, today's going to be probably a bad day because what are you going to have to start new music today? Yeah, that's going to be rough. Yes, Elliot.
I have a question with the sheet roll.
Yeah. Okay, so try starting number 2 on your own.
Should we play some anime song today?
Oh, I'm sorry. That's a great question.
I'm gonna
I don't know.
I'm sore.
Am I looking at the wrong paper?
That's what I'm down
I'm just blind. Okay, everybody, please go back to number 1. Elliot made a great point. I don't know why I didn't use. I'm so sorry. I am an old lady.
No, you're.
So how many significant figures should you actually have?
4.
Yes, my bad.
That's why I was confused.
I'm so sorry, Carter.
Oh, and then.
Mistakes were made. That's why it's important to pay attention when you're doing your work. All right, give number 2 a start. You're going to start it the exact same way. So I would start by writing NA equals, VA equals, NB equals, VB equals. And then fill those boxes in when you see a number.
Could we have killed someone if we didn't put the right significant figure?
No.
What about, like, is that even possible? No, it won't be possible.
If you rounded bad, it might be.
Because it's still the same number.
It is still the same number, yes.
This is when you go to this one. Is that cheese?
Okay. How are we doing? Do we remember how to, okay, so here it says HNO3. Is HNO3 an acid or a base? It's an acid. Okay, good. So that first number is an N, and it's of the acid. Stop making that sound. 5. Okay, let me know if I make another copying mistake.
You're good, you're
I'm
good.
just like confused, like, Bishop, where would we put it in the
Okay, so I know Carter that it's N because that number has an N right after it.
Okay.
So it has to be either NA or NB. But then the formula right after it in the problem is HNO3. And if it starts with an H, it's an acid.
Okay. And then if it's an NA, then it's a base.
If it's OH, if it ends in OH, it's a base.
So is there a point? How do you know what the V is then?
We'll identify that as well. So let's do the other N because there's only one other spot for an N. So that one is easy. Now we just have to figure about the V's. So I see that I've got a milliliters amount. It's 15.78. It's milliliters, so it has to be volume. But is it A or B? So you always want to look for the word of. Of will tell you what it is of. And so if you see milliliters of, and then the next formula that comes after that word of is what it is. So if it ends in OH, it is a base.
This Bishop, it makes sense now. Volume is with like liquids.
Okay,
And milliliters. Yeah.
got it.
How do we know if it's an after?
You just have to look at what, like, the next formula that comes after that number. If it ends in OH, it's a base, and if it starts with H, it's an acid. All right, so which of the formulas do you need?
VA equals NB times VB over N.
Okay, good. In the second column, you're going to substitute those numbers in for the variables. And so you'll have 0.255N times 15.78 milliliters divided by 2.597N. And then in the fourth column, but I ran out of room, you'll write your answer. Oh, not subtract. I got 1.549.
Yeah, that's perfect.
Is it 4 or 3?
Always.
How many significant figures do you need?
3.
3. 0.22255 has only 3 significant figures, David. Sorry, buddy.
Ooh, this Bishop is coming together.
Okay,
We're
good.
doing a test right now.
What's the unit?
We all.
I would maybe write what that's written on the blue on the board over there. I'd maybe write that down on my orange sheet. For test times, I would write it. How are we feeling about this?
Good.
Okay, it's not as bad as it seems. You just have to kind of be like chemistry problem detective. Let's do number 3, and then I'm going to give you the rest of the time as work time. We are going to do a lab on Thursday, and it's going to be a pants lab because we're going to do this titration. The procedure is very short.
Miss Bishop, what's the, on the board says number n equals NA or n what?
NB.
NB.
So if you've got any kind of number, and then after that number is big N, it has to be one of the N's. Okay, so I need to do my thing again. Excuse me. The first number is 0.325 N, H2SO4. Which of the 4 variables is that?
A.
Na. Well done. We know that it's Na because it has the N after it. And then it's got H2SO4, and if it starts with the letter H, it's an acid. Okay, so then I'm going to keep reading, and then it says 32.82 milliliters. Okay, so that's got to be one of the V's, but I don't know which one of the V's. So I'm just going to look for the chemical formula that comes after that number.
That's the base one.
It's the base. And then the last number that we're given goes
NB.
perfect. So that means VA must be question mark. And I think that's the same equation that we used last time, right? So we can just recopy that here. Oh boy. Substitute your numbers, making sure that your work is showing them that it's neat. You must keep your units with your numbers. Numbers can't have no labels, unless they're pH. And then, how many significant figures should your answer have? 3. I'm going to give you lab number 8. This is our acid-base titration. It's a pants lab because we're using an acid and a base. It's also a goggle lab. And can you get one to Elliot, please? Other than the slime lab, I would say when I ask people what was their favorite chemistry lab, this is the other one. Other than the slime lab. And just, yes, sir. I saw you looking at the ceiling.
Can I go for more water?
You may. If you want to use the rest of the time to work on your homework, or get this lab ready to go, or finish the lab from last time, that is totally fine.
I should probably actually do one.
You can do whatever you want to do. You've got about a half an hour to do that.
Miss Bishop,
Sure.
what's the answer
Did
that
you say that you're gonna hold your work and choke your chicken?
Carter?
You didn't even mean.
That's